So this is question 14 of the SPM 2019 at Maths paper 2. Right, we're supposed to use a graph paper to answer this question. So detach the graph paper, blah blah blah. Okay, so this is a linear programming question. Preparing prizes, and you've got X sets of pens and Y sets of notebooks. Okay, let's try that. So here we go. We have X sets of pens, Y sets of notebooks. Alright, straightforward. And set of pens costs 3 ringgit and set of notebooks costs 4. So that's RM3 each and RM4 each. Alright, easy enough. The purchase prices blah based on the following constraints. Okay, so here's your linear programming equations. Total number of sets of pens and set of notebooks must be more than 40. So obviously X plus Y has to be more than 40. Alright, so that's your first constraint. We have X plus Y needs to be more than 40. And your second constraint is total allocation is 400 ringgit. Alright, so obviously 3 ringgit of X, so 3X. 3X plus the cost of notebooks, which is 4Y, has to be less than or equal 400 because that's your budget. And finally, the number of sets of pens exceed the number of sets of notebooks, so X is greater than Y by at most 10. Right. So we have number of pens, subtract the number of notebooks, has to be less than or equal 10. Right, at most the difference is 10. Easy enough. Right, the three inequalities, well, other than X greater than or equal 0, blah, 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 they satisfy the above constraints, so we've already done that. Okay, so that's section A done. QED. Next, using a scale of 2 cm to 10 sets on both axes, construct and shade the region R which satisfies all the above constraints. Ooh, that's going to be fun. Let's get our graph paper. That's question 14. Don't get the wrong one. That's question 14. And through the magic of technology, let's see if this works. Ta-da! Right, we've got our graph paper. Right, so the first equation was X plus Y needs to be greater than 40. That's, again, quite straightforward. When X is, oh, hang on, let me just get some numbers on our axes. So red looks good. So we've got 0, 10 sets, 20 sets, 30, 40, 50, and so on and so on. That's your x-axis. And we've got 10, 20, 30 sets, 40, 50, 60, 70, oops, let's get this out of the way. 70, 80, 90, 100. Right, so the first equation was X plus Y is greater than 40. So that's a straightforward straight line right there. When X is 40, when X is 0, Y is 40, and Y is 0. X is, there you go, and that's that, right? And so we've got, let's just write this down, X plus Y is greater than 40. So it's greater than, not equal, so obviously it's got to be a dashed line, so that's your region right there. And your second equation was 3x plus 4y less than or equal 400. So we've got 3x plus 4y less than or equal to 400. Again, substitute 0 to x, that gives you 100, y equals 100. It's pretty straightforward. And you've got an inclination of 4 to 3. So 4 boxes to 3 boxes right there. See that? You see the 4 boxes to 3, and through the magic of technology, we draw a beautiful straight line. Come on. Okay, and it's less than or equal, so it's a solid straight line, and this is the region required. Okay, so that's that line. So far so good. And finally, x minus y less than or equal to 10. Oh, that's the easiest one. So we've got x minus y is less than or equal to 10. Sorry about the handwriting. So that's obviously a straight line with a straight line with an inclination of 1. Let's see if we can get this right. So it intersects 1 right here, and it's less than or equal. How nice. So that's that, and that's y greater than or equal x minus 10. Alright, so this is region R. Alright, that little 1, 2, 3, 4-sided zone there. I mean, obviously you've got a straight line here as well. Let's get the ruler out of the way. There we go. Okay, that's enough. Right, so that's the second section done. Where are we? There we go. Using a scale of blah blah blah, sketch out region R. So we're done. Right, so use the graph, section C, use the graph blah 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 to find the answers to the following question. Minimum balance allocation in the number of sets of pens is equal to the number of sets of notebooks. Right, so obviously that constraint can be expressed as x equal to y. So if we were to draw that, let's pull out our handy little ruler again, set it to 45 degrees, and draw it right there. And you'll find the answer is, oh, I don't know, it looks like 56, 57, something like that. Right? If you really want to work it out, right, we can simply go, well, B, C, the sketch, right, the graph, and now C. Let's equate x equals y, which was a constraint, and the allocation constraint, which is the budget, is 3x plus 4y less than or equals to 400. So let's substitute, oops, so let's substitute this into this, and that gives you 3x plus 4x less than or equals to 400. Okay, so that's pretty straightforward, just work that out. Take our handy calculator, 400 divided by 7, 57.14, and since it's an integer, so it will just say x is equals to 57, which is also the amount for y. Alright, so that's your actual answer, and the answer from the graph was about, yeah, kind of looks like 56, 57. Okay, so let me see. Find the minimum balance with allocation. Ooh, that's a tricky one. So the real answer is not that. Right, so the balance obviously is equals to the budget of 400 minus 7 times of 57, which gives you 1. 57 times 7, very conveniently, is 399, right? So we've maxed out our budget. That's the answer. Right, so let's have a look at question C2. Right, Determine the maximum number of sets of pens that can be purchased if Citi spent 50 ringgit on wrapping papers. Okay, so your budget has essentially been reduced, right? So instead of having a budget of 400, you've lost 50 ringgit. Okay, so let's try and figure this out. You need to draw a line that says 3x plus 4y less than or equals to 350. So let's set x equal to 0. Your y-intercept would be 350 divided by 4, which is 350 divided by 4, 87.5. Lovely. So let's set our inclination to -4.3 and drop the intercept down to about 87.5 right there. So for the heck of it, let's just change colors to green. So that's our new budget line, because Citi wasted 50 bucks on our wrapping papers, right? So it's asking us what's the maximum number of, I should really transform this to some other color. Okay, the maximum number of pens that we can get. So we're looking for max X, right? So it looks like that spot, which is about, I don't know, looks like 56 maybe. Yeah. So if you really want to work that out, okay, so that was C1. Okay, so let's do C2. Okay, so from the graph, it's X is approximately 56 max. Okay, if you really want to work that out, you simply have to find the intersection between that green line and this line, right, which is your x plus y greater than 40, and that's quite easily done. So let's have 3x plus 4y. Let's just set that to equal to 350, your new budget. And we've got x minus y equals to 10. So if you substitute that into that, you get 3x plus 4 into x minus 10 is equal to 350. And work that all out, we have 7x equal to 390 and x is equal to 55.7. Alright, so yeah, maybe max x equals to 55. And let's see what that looks like in our graph. Yeah, it looks about there. So obviously if you draw that a lot more accurately, you'll get a better answer. Okay, and that is question 14.